you, sir.
First time, Abdullah. So, Abdullah, did you try the assignment?
Yes, sir. I solved all the questions except the last one. I have one doubt.
Okay, just give me 1 second. I'm asking this question to share assignment. What about the rest? Sania, Fatma, did you try the assignment?
Yes, sir. I did the first and second. The third one, I didn't get the answer. Fourth one, I couldn't do.
Okay, just why,
Sir.
Sania? Yes, Abdullah.
Sir, what do you mean by equiconvex lens?
Means a lens having a same radii of curvature on both the sides.
That is same like biconvex lens.
Yeah, biconvex means both the surfaces are convex, but it can have different radius of curvature. But when you say equiconvex, that means radius of curvature on both the sides is same. Just give me 1 minute. I'm waiting for the assignment. Let him share the assignment.
Yes, sir.
So when are your sessional exams in school?
Sir, no idea.
And result?
Written one?
And what about the result? For the first one?
Written one?
Sorry?
CBSE has not said anything about the result. They are just postponing the dates. But now
Okay.
it's in third week.
Okay. That was the assignment. Yes.
Then question
So,
number two. Question number two, I applied that radius of curvature of both the ends are same, and I got the answer.
okay. Okay, I'm solving all questions. I just won't take more than 1 minute in a question. So, radii of curvature of the faces of a double convex lens are 10 centimeter and 15 centimeter. If focal length is 12, what is the refractive index of the glass? So, let's apply Lensmaker formula. 1 by f is n2 by n. n21 is n2 by n minus 1, 1 by r1 minus 1 by r2. So, when you have a double convex lens, this is a double convex lens. This is the pole P1. This is center of curvature C1. This is pole P2, and this is the center of curvature C2. So this P1, C1, this is R1, it's positive. R1 is plus 10. And this is 15, so that's R2. So light is going in this direction, moving in a direction opposite to that of light, so it's minus 15. And the focal length is 12 centimeter. This is plus 12 because it's a convex lens, so focal length is positive. So everything is given. Let's substitute these values. 1 by f is 1 by what? 1 by 15? No, 1 by 12. Is n2 by n1. n2 is glass. So refractive index is not given. n2 is not given. n1 is the refractive index of the surrounding medium. Nothing is given. That means surrounding medium is here. Minus 1. Then it's 1 by r1 minus 1 by r2. 1 by r1 is 1 by 10. Minus 1 by r2 is minus of minus 1 by 15. Minus 1 by 15. So we have 1 by 12 is it's n2 minus 1. So it's 1 by 10 plus 1 by 15. 1 by 10 plus 1 by 15. So which implies 1 by 12 is n2 minus n, n2 minus 1. If I take LCM of 1 by 10 and 1 by 15, LCM comes out to be 150, right? So that's 15 plus 10. So you can write 1 by 12 is n2 minus 1. 15 plus 10 is 25. So it's 25 by 150. So when you cancel them out, it's 4, 5, 6. 1 by 6. So which means 1 by 12 is n2 minus 1 divided by 6. This 6 will cancel this 12. You get 2. So you have 1 by 2 is n2 minus 1. Take reciprocal on both the sides. So we'll get, or not reciprocal, just add 1 there. Yes, Fatma and Abdullah, you tried this question. You getting the same answer?
Yes, sir.
Yeah, I got 1.5.
Very good. So n2 is 1 plus 1 by 2, it's 1.5. Very good. So those who have not yet attempted this question, just note it down. Then do the second question. This is of question number 1 of assignment. Just note it down first. Sanya, note it down.
Yes, sir.
Anyone else tried this assignment? Amalia, Ahmad, Mariam was absent. Nazira? No one. Okay, noted. See the next question. The next question is a biconvex lens has a focal length 2 by 3 times the radius of curvature of either surface. Calculate the refractive index of the lens material. So it's a biconvex lens have focal length 2 by 3 times the radius of curvature of either surface. So either surface means the radius of curvature of both the surfaces are same. So when you have a convex lens, see R1 is plus R. I'm using the sign convention directly. I have shown this thing in the previous question. R2 is minus R. Focal length is 2 by 3 times the radius of curvature. I need N. See, N1 is not given. That means N1 is here. Let's apply Lensmaker formula again. This is Lensmaker formula. Just substitute these values here. Instead of F, you can write 2 by 3R. This will be 1 by 2R by 3, which is equal to N2 by N1 minus 1. N2 is unknown. N1 is here, so that's 1 minus 1. 1 by R1 minus 1 by R2. R1 is R, R2 is minus R. So it's 1 by R minus 1 by R. So this 3 will go to numerator and you will have 3 by 2R is N2 minus 1. 1 by R plus 1 by R, it's 2 by R. So see, this R will cancel this R. And you will have 3 by 2 is N2 minus 1 multiplied by 2. You can take this 2 to the denominator. When you bring this 2 to the denominator, you will get 3 by 2 into 2 is N2 minus 1. So which means 3 by 4 is N2 minus 1. You can take this minus 1 to the left hand side and you will get 3 by 4 plus 1 is equal to N2. So 5 plus 1 is 7, which means 7 by 4 is N2. So this is N2, which is 7 by 4. Abdullah, you're getting the same answer?
Yes, sir.
Fatma? Yes, Fatma, you're getting the same answer of this question?
No, I got 3 by 4.
But 3 by 4. Note it down. Those who haven't attempted this question, just note it down. Second question of the sign. Yes, is it clear? Written, everyone?
Yes, sir.
Yes, sir.
Sure. Question number 3. You have a convex lens of focal length 0.2 meter and made of glass is immersed in water of refractive point to change the focal length of the lens. Sure. So in air, focal length is 0.2. You're supposed to calculate focal length of the lens in water. So at least from the first 2 questions, you get an idea that for a double convex lens, your R1 is positive, R2 is negative. So I will not write the sign convention again and again. So this is 1 by F. It's N2 by N1. N2 by N1 minus 1. 1 by R1 minus 1 by R2. The first one is positive and second one is negative. This we know from the first 2 questions. It's in double convex lens, we always use this convention. So you will get 1 by F is N2 by N1 minus 1, 1 by R1 plus 1 by R2. So when you substitute the values, the focal length is 0.2 meter. So it's 1 by 0.2. It's N2 by N1. So N2 is 1.5 And initially your surrounding medium is air. N2 is 1.5 and surrounding medium is air. So it's 1 minus 1. It's 1 by R plus 1 by R. That's my first equation. So when you change the surrounding medium to water, like you dipped your lens in water, so instead of N1, you will use 1.33 now. So instead of this N1, which is 1 here, you will use 1.33. So let's say in water, the focal length is 1 by FW. The refractive index of glass is same. N2 is same, N1 is changing. Instead of 1, you are using 1.33 minus 1. 1 by R plus 1 by R. That's equation. Now what you can do now is you can just divide them. This will cancel this thing. You can take FW to the numerator. This is focal length in water by 0.2. This is 1.5 minus 1, so that's 0.5. 1.5 by 1.33 minus 1, so it's 1.50 minus 1.33 by 1.33. This will come to numerator. So we'll write focal length in water divided by 0.2 is 0.5 into 1.33 divided by 1.33, and this is 0.17. So you can write that focal length is it's 0.5 into 1.33 into 0.2 divided by 0.17. This is the focal length. So this is the focal length of the lens. 0.5 into 1.33 by 0.17 into. Note it down. If you look at previous year's questions of CBSE, like All India, India, Foreign, you will find all these questions in your previous exams. Then we'll go to the last question. Tell me once you have written. Noor, did you try this assignment? Are you clear?
Yes, sir.
After this, the next topic is the next question, last question. An equiconvex lens of focal length 15 centimeter is continued to equal half the shown in figure of the focal length of the east. So see, this is 4. So this is your equiconvex lens. So equiconvex lens means radius of curvature of both the surfaces are same. Like if I write R1 as plus R, then your R2 is minus R. Radius of curvature is same. They just have a sign difference of sign. So when you write the focal length, it's 1 by F. You can write this as it's N2 by N1. Or let's write this as N2 1 minus 1. 1 by R minus of minus 1 by R. So you can write that focal length 1 by F is it's N2 1 minus 1. It's 1 by R plus 1 by R, it's 2 by R. This is first equation. Now he's saying that cut this lens. And how to cut this lens? Through in this way, perpendicular to the axis. So when you cut this lens in this way, perpendicular to the principal axis, this is how. So when you cut this lens, you will get these two lenses. You're supposed to calculate the focal length of each of the following lens. To get the focal length of this lens, what we can do is, this is, what type of lens is this? Is it a double convex lens or a plano convex lens?
Planar convex.
That's a plano convex. So what happens in a plano convex lens is, one is spherical, curved, it will have some radius of curvature, another is plane. The radius of curvature of the plane surface is infinite. So this will have first surface and this is your second surface. First surface will have some radius of curvature which is plus r. See, radius of curvature of first surface is not changing. Earlier it was plus r, now again it's plus r. But how much is r2? What about the plane surface? So infinite. Plane surface, you can consider that plane surface is a part of sphere having infinite radius. So your R2 is infinite. Now let's substitute these values in Lensmaker formula. 1 by f prime is n21 minus 1. 1 by r1 minus 1 by r2. So instead of 1 by r1, you will write 1 by r. 1 by r2, instead of r2, you will write infinite, and you will get 1 by f prime is, it's n21 minus 1 into 1 by r now. That's equation number 2. Next, what we can do is we can just divide one into. So when you divide one into, equation, then you get 1 by f divided by 1 by f prime is n21 minus 1 multiplied by 2r, 2 by r. This was 2 by r, I guess. So this was 2 by r. Divided by its n21 minus 1. It's 1 by r. N21 minus 1 will cancel this n21 minus 1. R will cancel this r. You can take this f prime to the numerator. So we'll get f prime by f is 2, which implies f prime is 2. Means when you divide a lens into half, the focal length will get doubled. Focal length will be doubled. This is it. This is the question. Good. Please go ahead. Written.
Yes, sir.
Is it clear? Written? Noor, Ahmed.
Yes, sir.
So that was about lenses. There are few more questions on 10 lenses, just two more questions. There's one question in which you have to complete the ray diagram. See, the question says this is the lens. So okay, we have done enough questions with the convex lens. Let's do some question with the concave lens. So this question can be repeated with convex also. Let's do it with the concave lens. So this is a concave lens. Refractive index of the surrounding is n. Refractive index of the medium of lens is n. You incident two parallel rays over the lens. The question says complete the ray diagram. Complete ray diagram if first part n2 is greater than n. Second part n2 is less than n. Third part n2 is equal to n. Okay, what type of lens is this concave lens? Concave lens is converging or it's diverging? Yes, usually a concave lens is a diverging lens, but a lens will converge or diverge. That along with the geometry will also depend upon the refractive index. You will see that this concave lens in first condition will diverge, as you said. In the second condition, this concave lens will start converging. And the third condition, this concave lens will do nothing. It will neither converge nor diverge. So it will converge or diverge. That depends upon the relation between the refractive index of surrounding and the refractive index of medium. Let's do it. So this is a double concave lens. So let's mark the center of curvature. This is P1. See, the first surface will complete sphere on the left hand side. So this is C1. The second surface will complete sphere to the right hand side. So this is C2. So this is the radius of curvature R. And this is the radius of curvature, which is R. So who will tell? Nazira, R1 will be positive or negative? This R1, the radius of curvature R1, it will be positive or it will be negative? Sorry, I can't hear you. Positive or negative? What you said?
Negative.
Negative, very good. It will be negative, Sania. See, light is going to the right hand side direction, but you are going from P1 to C1, means you are moving in a direction opposite to that of light. So your R1 will become negative. Sania, now try. What about R2? Start from P2 pole and go to C2. P2 to C2. Light is to the right. You're going in the direction of light or opposite to the direction of light, Sania? Yes, you're going in the direction of light, so your R2 will be positive. So when I apply a Lensmaker formula, so I get 1 by F is, it's N21 minus 1. First surface is negative, so it's minus 1 by R. Its second is positive, so minus 1. See, in Lensmaker formula, we write 1 by R1 minus 1 by R2, but R1 is negative. That's why minus 1 by R1 minus 1 by R2. So this is the focal length. So if your focal length comes out to be negative, then lens will diverge. If it comes out to be positive, then your lens will converge. So let's check all cases one by one. First case, if N2 is greater than N1. If N2 is greater than N1, that means N2 by N1 will be greater than N2 by N1 will be greater than. Or you can say that N2 by N1 is nothing but N21. N21 is greater than N21 minus 1 is greater than 0. It's a positive term. See, N21 is greater than 1. You're subtracting 1 from something which is greater than 1. So it will be a positive quantity. Now look at this formula. It's N21 minus 1 minus 1 by R1 minus 1 by R2. So what do you think? This comes out to be positive and this term is negative. So what do you think? What's the focal length? It's positive or negative?
Negative.
Negative. Negative means your lens will diverge. You have a diverging lens. Your concave lens will diverge. So when you complete the ray diagram, this will go like this. This is concave lens, so incident parallel rays, and the rays does not converge, they diverge. This is it. Let's do the second part. In second part, N2 is less than N1. So your N2 by N1 is less than 1. You can write that your N21 is less than 1. Your N21 minus 1. Yes. Is it positive or negative now? You're subtracting 1 from something which is less than 1. So it will be positive or negative?
Negative.
It's negative. So when you use Lensmaker formula, we have 1 by f is it's N21 minus 1. It's minus 1.
Positive.
Sorry. Minus 1 by R1 minus 1 by R2. So it's negative. So this term is negative. This is also negative. So your focal length is positive. Amalia, if focal length is positive, then what type of condition is this? Is it converging or diverging? Amalia, what type of condition is this? This is for a converging condition or the diverging?
Converging.
Converging. This will converge. So when it converge, this is one surface. This is second surface. You incident parallel rays here. The rays will converge. This is converging. Third case. If I say N2 is equal to N1, that would mean that N2 by N1 is equal to 1. N21 is 1. N21 minus 1 is 0 because it's equal to 1, so 1 minus 1 will be 0. If I make these substitutions in the Lensmaker formula, then I get N21 minus 1 minus 1 by R1 minus 1 by R2. See, the first term is 0. So 1 by f will be 0, which implies f, if you inverse it, it will be 1 by 0, which is infinite. So focal length is infinite. Infinite focal length means that this lens will neither converge nor diverge. If this is it, the rays will go straight. It's neither converge nor diverge. It's like nothing has happened. There's no refraction. You get refraction when the refractive index of the medium changes. There is no change in the refractive index of the medium. There is no refraction. The rays goes as it is, goes straight without any refraction. So we call this as there is nothing happens here. In fact, if you put a lens of refractive index equal to that of a surrounding, then you can't even see this lens. The lens will disappear. This is same as saying that I have a lens of air in my, obviously I can't see the lens of air in air. But if I have a lens of air in water, then I can see it. You can see objects if they have different refractive indices. There is some refraction going on. But if I say that I have a lens of air in my, that means I can't see that lens. So this is what exactly happening here. It's like you take a glass of water, fill that glass with water, and you say inside the water I have a lens made of water. You can't see that lens. You can see a lens only if the medium of lens and the surrounding have different refractive indices. So the lens will disappear. This is what magicians do in very cheap tricks. What they do is that they will show you a lens and will say, okay, I will disappear this lens. So they put that lens into a liquid having refractive index of almost the same as that of lens, around 1.5. So in that liquid, you can't see the lens, and it seems like that lens have disappeared. If you keep any object between two lenses, the object disappears. Why, Abdullah? Is this surrounding also now? Instead of those two lenses, there is surrounding medium also. But if that object have the same refractive index as that of lens, then it will get disappeared. If you
There
take
is
it,
no.
sorry. No. If you have the refractive index of the object is same like that of the lens, then only you can disappear. So the same question can be repeated for a convex lens. You will get similar type of results. In some cases, it will behave like a converging lens, then it can behave like a diverging lens, and it can not behave as like a lens at all. If n2 is equal to n1, then ray will go straight without any refraction. Hello, what is Super 30?
Yes, sir.
What is Super 30?
It's a movie.
Okay, that. So you watch Indian movies?
Yes, sir.
Yes, sir.
Okay. What are your next plans? 12th is almost over. Just 1-2 months and then 12th is over. Going back to Pakistan, Abdullah, for your graduation.
I haven't thought of something like that.
Start thinking now. You just have 2-3 months.
Yes, sir. I'm searching for universities, but I'm not getting a proper one.
If you're looking for something in US or Europe, you should apply for SAT. First of all, just apply for SAT.
Yes, sir. I have plans for SAT only after 12. First I'll clear SAT, then
It's not just for Abdullah, for every one of you. Start thinking about what the next plan after 12th. Germany is a very good place for graduation. Get admitted easily in the colleges, but the issue with Germany is you have to learn German language.
that's the problem.
Language is not problem at this age. At your age, you can learn any language very easily.
But sir, for that we need a course, and for learning a course we need 6 to 7 months.
No. You can learn. They can learn German in 2-3 months. Winter in Germany, you need a very basic German, like hi, hello. Like you all must understand Arabic for now at least. So when you live in a particular country, you get the language. At your age, language is not an issue. After 35, after 40 years, learning new language is an issue. Germany is a very good option.
Okay, sir, I'll try.
Okay, written.
Yes, sir.
Yes, sir.
So that is the one last question on Lensmaker formula, and that is for goggles, sunglasses. See, the sunglasses are plane surfaces or they are curved?
Uh,
Oh,
Sunglasses are curved. Does sunglasses have any power?
no, sir.
No. Power of sunglasses is zero. Power of sunglasses is zero. Power is basically 1 by focal length, which means the focal length of sunglasses is, if power is zero, means 1 by f is zero. Means how much is focal length?
infinite.
Infinite. So what is there in a sunglass which gives you infinite focal length? For infinite focal length, you can have a plane surface, but sunglasses are not a plane surface, they are the curved surface. So what happened in a sunglass? A sunglass is a convex to concave lens. You have one convex surface, another concave surface. It's a convex to concave lens. One convex and another concave surface. You can say this is these type of lenses. The radius of curvature of both the surfaces are same. So one is plus r, another is also plus r. Both have same radius of curvature. So when you put this in Lensmaker formula, you get 1 by f is n21 minus 1. It's 1 by r minus 1. See, this r and r will cancel out. So 1 by f is 0. So you get f equal to infinite. So lens sunglasses have infinite focal length. Infinite focal length means 0 power. It's a very common question on sunglasses. What type of lens is a sunglass? Sunglass is a convex to concave lens, where the radius of curvature of both the surfaces are equal. Both the surfaces have equal radius of curvature. That's the reason it's a curved lens, but power is 0. It's a curved lens, but focal length is infinite. Let's start it up. That's the last question on Lensmaker formula. We'll do lens now. No. Let's start lens. Tell me once you have written. Change the slide. Yes, everyone written.
Sir.
See, so Lensmaker formula is over. The next is image formation through a lens. So that's the next topic. Lens again. But now it's lens formula. See, the derivation of lens formula is not in syllabus now. We'll derive it, but first let's do few numericals. Let's complete this topic. At the end, we will do the derivation of lens formula. So the lens formula is the relation between the object distance. So relation between the object distance, the image distance, and focal length of lens. So the relation between the object distance, image distance, and the focal length of the lens is known as lens formula. Take a lens. We write this as 1 by v minus 1 by u is 1 by f. This is valid for both convex as well as concave lens. So when you use this relation into a numerical, you should be using proper sign convention. We always use sign convention when we use lens formula. After lens formula, there is one more thing which is known as magnification. To be particular, this is linear magnification. It's a linear magnification. So see, what does this linear magnification means? Linear magnification is the ratio of the height of image and height of object. The ratio of height of image and height of object is known as linear magnification. You can write this as, there is one more formula for it. You can write this as V by U. Or if you want, you can convert it in terms of focal length also. F by F plus U.
It is
can-
minus C by U, right?
Sorry,
Minus C by U or V by U?
it's V by U. Minus V by U is for mirror. So when you use this in numerical, use a proper sign convention. Minus V by U is for mirror. It's height of image by height of object. And there's one simple sign convention that height above the principal axis is positive. Height above principal axis is positive. And below the principal axis is negative. So height above the principal axis is positive and height below the principal axis is negative. Okay, note it down. We'll do numericals on it. Yes, written.
Yes, sir.
There are few more relations for magnification. You can write this as, it could be written as F by F plus U. Or you can also write this as F minus V. So these are four relations for calculating magnification. So it's just the ratio of height of image and height of object. That's it. See, next. After this definition of linear magnification, there's few more things that one should know about magnification. If magnification comes out to be negative, this means that your image is inverted with respect to object. If it is negative, that means your image is inverted with respect to object. If your magnification comes out to be positive, this will mean that your image is erect with respect to object. If your magnification is greater than 1, This implies that means your image is magnified. Image is magnified. If your magnification is less than 1, this means that your image is smaller than the object. Image is diminished. So if you have magnification, that means you have all information about the object. And one more thing, if it is inverted, then it's real image. Real image is always inverted. If it is an erect image, then this is virtual. Virtual image. No, we'll do few questions over it. Written?
Yes, sir.
Okay, let's do a formula based question first. For a convex lens, of focal length, let's say the focal length is some 40 centimeter. Not 40. Let's keep it 10 centimeter. Object is placed at, let's say, 20 centimeter. So what type of focal length is this? Is it positive or negative?
Positive.
Yes. It's positive or negative?
Positive.
Positive.
It's a convex lens, so focal length will be positive. I need image distance. I need magnification. Then I need height of image. If for object it's 2 centimeter. Last I need image distance is over. Magnification is fine. Height of image, if for object it's 2 centimeter. Height of object is this. And nature of image. Means you have to tell whether your image is erect, virtual, real, inverted. Do it. Use this lens formula for image distance. Use the relation for magnification. And while using these relations, remember you have to use proper sign. Don't ignore sign convention. And this time I need answer from each one of you. This question is from class 10th NCERT. In 12th, you won't get these type of straightforward questions. You will get some modifications. Wait, tell me how much is image distance? Okay, Ahmed. Ahmed, just check your calculations once more. I think you're making some mistake. Noor seems correct. What about the rest? Fatma, Sania, Nazira. Just put the value of U and F in lens formula. Good, Abdullah. No, is it with positive sign or with the negative sign? See, this is your lens. This is your object. This distance is 20 centimeter. Huh? Try to decide whether this distance is positive or negative because sign convention is important. Mariam. Good. Very good, Sani. You're getting the right answer. Ahmad, it's wrong. No, Fatma, it's wrong. You're making some mistake. You're making mistake in sign convention. You and Ahmad are making the same mistake. You take U as negative. Fatma, take U as negative. Yes, Noor. Third part is also correct. No, Ahmad, again, just check your calculations once more. Amalia. Yes, now it's correct. Yes, Fatma, now you are correct. Mariam, Nazira, Sania. Right, Noor. Good. Yes, Amalia. First is correct, second also correct. Mariam, what about your answer? Sania. I'm waiting for this 200. No, Sania, first is wrong. Just check your calculations. You're making some mistake in subtraction again. No, Fatma. Just check your calculations again. Right, you are correct. It's correct. No, Ahmed, wrong magnification. Right, Nazira. First is the sign is wrong for first one. First one, the answer would be positive. Sania, first is correct, second is wrong. Ahmed, second is wrong. Mariam, we are not solving. See, this is a formula based thing. Huh? Your object distance is minus 20 centimeter. It's a converging lens, so focal length is positive. So you have, good Amalia, it's correct. 1 by V minus 1 by U is 1 by F. Right, Mariam, it's correct. 1 by V is 1 by F plus 1 by U. Right, Fatma, it's correct. Third part is also right. So you get 1 by V is 1 by F, which is 1 by 10, plus 1 by U, which is minus 1 by 20. So 1 by V is, you take LCM, it comes out to be 20. 10 2s are 20, it's 2 minus 1, so it's 1 by 20. So if we get V, which is 20 centimeter. This is final velocity V. So not velocity, image distance, which is 20 centimeter. That's the first one. For second part, you need magnification. Magnification is V by U. But substitute all values with proper signs. See, V is 20, U is minus 20. So it comes out to be minus 1. So magnification is minus 1. Not. So once you have magnification, you can get the height of image also. See, height of image by height of object is magnification. It shows height of image by height of object is equal to minus 1. Which means height of image by height of object is 2 centimeter. It's minus 1. So which implies that height of image is minus 2 centimeter. This is the height of image. That's minus 2 centimeter. After this, the last part is nature of image. See, magnification is negative, right? Negative means your image is real and inverted. Mod of M is 1. Means image is same size as that of object. Same size of object. So this is clear for everyone. So Amalia, it's if magnification is negative, that means it's inverted. If it is inverted, then it has to be real. Let's do another question. Do this question. This is from the previous years. You have a needle. It is placed 9 centimeter, 45 centimeter from a lens. Forms an image on a screen. Placed 90 centimeter on the other side. Other side of the lens. Identify the type of lens. And calculate its focal length. What is size of image is size of needle is 5 centimeter. Do it.
So,
Yes.
sir, the 90 centimeter distance is from the lens or from the object?
Which one? 45?
90 centimeter distance. It is from the
90 centimeter on the other side of the lens. Means from the lens. So you have lens. 90 centimeters on the other side of the lens. This is the lens and this is your image. This is 90 centimeters. So it's basically your image distance for the positive side. So it's easy. You have object distance. This one is the object distance. This is image distance. You just have to calculate the focal length. Once you get the focal length, then just by looking at the sign of focal length, you can decide whether your lens is converging or it's a diverging lens. Good, Ahmed. Very good. Right answer. Good, Sania. Correct answer. So focal length comes out to be positive. That means your lens is convex lens, right? If it is positive, then the lens is convex. Gudur. Fatma, Nazira. Just put the values in Lensmaker formula, nothing else. Oh, sorry, lens formula. Right, Abdullah, all parts are correct. Good, Ahmed. Magnification is right. Now get the height of the image also. Right, Sania. The image is height is correct. Mariam, Malia, Fatma. Good, no, it's correct. Right, Fatma, it's correct. It's correct. No, Fatma, for first it's not 90. That 90 is image distance. Good, no, it's correct. Yes, Fatma, it's right. Mariam, Nazira. Yes, Nazira is the correct answer. C. Yes, Ahmed, you are right. It's correct, Mariam. First part is correct. See, your object distance. Right, Mariam, it's correct. Object distance is minus 45 centimeter. Your image distance is 90 centimeter. Yes, Mariam, both the parts are correct. Good. You need focal length. Huh? So it's 1 by V minus 1 by U. It's 1 by F. So if I substitute values, 1 by 90 minus 1 by minus 45. Huh? It's 1 by F. So when we take LCM, so it will be 1 by 90 plus 1 by 45 is 1 by F. So when you take LCM, it's 90. It's 1 plus 2 is equal to 1 by F. It's 3 by 90 is equal to 1 by F. So which implies, so 1 by F is 1 by 30. So it implies focal length is 30 centimeter. Focal length is 30 centimeter. That's the focal. So once you have focal length, you can get the value of magnification. Magnification is V by U. So V is 90, U is minus 45. So when you cancel them out, it comes out to be minus 2. Magnification is minus 2. Magnification you can write as height of image by height of object is minus 2. So the height of image is not given. Height of object is 5. So height of image, height of object, which is 5, is equal to minus 2. So we have height of image as minus of 10 centimeters. Almost everyone was getting the right answer. Just note it down. Then we'll do combination of lenses. What if you have multiple lenses in contact? See the next part. The next question is not the next question. Let's do the next part from theory. That's the last part of refraction, which is known as combination of thin lenses in contact. Let's do one more topic. Power of lens. See, power we have already discussed. Power is just 1 by focal length. Power of lens is 1 by focal length. So if I talk about the SI unit, SI unit of power is diopter. So to calculate power, your focal length should always be in meter. Never keep focal length in centimeter and try to calculate power. To calculate power, F is in meter. Focal length should always be in meter if you want to calculate power. If you have a converging lens, then power is positive. For a converging lens, P is positive. For a diverging lens, power comes out to be negative. That's power for a lens. For converging, if you have a converging lens, then your power will be positive. For a diverging lens, the power is negative. After power, we have combination of just note it down, then we'll do the combination of it. And always remember while doing this power that if you have sunglasses, the power of sunglasses is 0 because both the surfaces have same radius of curvature and they are of opposite nature. One is convex and other is concave.
Yes, sir.
See, the next is combination. So you have a combination of any type of lens, means you can combine one convex lens, another convex lens, or you can combine them with a concave lens also. Can combine them with a concave lens also. So you can have any type of lenses, concave, convex, plano concave, plano convex. You can have any type of lenses. But the condition is all these lenses are thin lenses and they are placed in contact. There is no separation between the lenses. There is one theory also exists which says to solve the lenses when they are placed at some separation, but that is not in your CBSE syllabus. So you have lenses and they are placed back to back. There's no gap between the lenses. This is first lens have focal length f1, second lens have focal length f2, third lens have focal length f3, fourth lens have focal length f4. So first of all, you need equivalent focal length. Equivalent focal length means you want to remove all these lenses. Equivalent focal length. You want to remove all these lenses and place a single lens. So you can say that 1 by F equivalent is 1 by f1 plus 1 by f2. See, concave lens have negative focal length. We'll put this with the negative sign. Plus 1 by f4. So place all lenses and so on with their proper signs. So that's F equivalent 1 by f1 plus 1 by f2. If you have concave lenses, then take those concave lenses with a negative sign. Now, if your F equivalent comes out to be positive, if it comes out to be positive, that means system is converging. It will behave like a convex lens. System is converging. If your F equivalent comes out to be negative, then your system is diverging. System is diverging. Another thing here is this power, equivalent power. Simply add all powers, P1 plus P2, this is minus of P3 plus P4. While adding power, keep this thing in mind. If you have a convex lens, then power is positive. Take it with a positive sign. If you have a concave lens, then power is negative. Take it with a negative sign. And the last is the equivalent magnification. Equivalent magnification. So equivalent magnification is simply the product of magnification of individual lenses M1 into M2 into M3, just keep on multiplying. So focal length get added up, power get added up, but this magnification get multiplied. So this is the combination of lens. Let's note it down. We'll do a few questions on it. Yes, noted.
Yes, sir.
Next question. So the question says, convex lens of focal length plays in contact with concave lens of focal length 5 centimeter. Calculate focal length and power of combination. Good. Answers. Good, Noor. Good, Ahmed. What about the rest? Right, Ahmed. Power is also correct. No, some issue in the power. Just check your power expression of power. Yes, Abdullah. Both are correct. Sania, Mariam, Nazira, Fatma. Shahzada, you're very late. And where were you in the last few classes? Shahzada. Okay. So refraction is completed, Shahzada. Just try to go through this recording before the next class. Huh? Just text Nishkarsh and take recordings from it. No, Nazira. Amalia, it's correct. No, Nazira, I don't think it's 3 centimeter. No. No, Sani, it's wrong. See, you can write that your 1 by f equivalent is simply, it's 1 by 10 minus 1 by 5, right? So you can take as LCM. 10 is LCM. It's 1 minus 2. It's minus 1 by 10. So your f equivalent will comes out to be minus 10 centimeter. That's f equivalent. Now, to calculate power, first convert this f equivalent into meters. So to convert centimeter into meter, you divide it by 100. Huh? Then your power equivalent power is 1 by f equivalent. So if you take inverse of it, comes out to be minus 10 diopter. That's the equivalent power. Note it down. Yes, written.
Yes, sir.
Yes, sir.
Okay. There's another question give from NCRT. So you have 3 lenses back to back. So you have 3 lenses. This is first lens. Its focal length is plus 10 centimeter. Then this is second lens. It's a concave lens. Its focal length should be negative. It's minus 10 centimeter. Then you have another convex lens. Its focal length is 30 centimeter. The separation between the lenses is given. So they are not placed back to back. This is 5 centimeter. This is 10 centimeter. And this is the object. This is the object. 30 centimeter. I need position of image. It's a lengthy question. We'll do it together. Find position of image. First of all, tell me, can you use that equivalent focal length wala relation here?
No, sir.
No, you can't use that relation. Why? Why can't you use that relation here?
Because the distances between the lenses.
Yeah, because for to use that relation, this one by this one, your lenses should be placed back to back. There should not be any separation between the lenses. But since there is separation in the between lenses, that formula will not work. So that's a lengthy problem. You have three lenses. For each of the individual lens, you have to solve lens formula. Just note it down. It's not tough, it's just lengthy. Just note it down. We'll do it together.
Size of the object.
Sorry,
Size of the object.
Ahmed, your voice is not clear.
Say, is there any size of the object?
Any size? No,
Okay.
no size of the object. Ahmed. No size of the object. Size is not given. Just have the need position of image. So let's do one thing. Everyone have draw this diagram?
One
Yes,
second.
sir.
Okay, just draw the diagram, then I will tell you how to solve these type of problems. This is a solid example of NCRTs. It's quite important.
Done, sir.
So let's start with lens one. So for lens one, how much is the object distance? That's minus 30 centimeter. For lens one, what is the focal length? Focal length is plus 10 centimeter. Apply a lens formula and get the value of image distance for the lens first. Do it and write your answer in chat. Do it fast. Just put these values in the lens formula. 1 by V minus 1 by U is 1 by F, and get the value of V1. How much is V? Good, Abdullah. Good note. Anyone else? What about the rest? Just substitute values. I need V1 only. No, Ahmed. I'm making some mistakes. Some mistake. Amalia, just look at the sign. I don't think it will come with a negative sign. I think it should come with a positive sign. So when we substitute values, 1 by V1 is 1 by F1, it's 1 by 10, minus 1 by 30. So we have 1 by V1, which is, you can take 30 as LCM. It's 3 minus 1, it's 2 by 30. So it's 1 by 15. V1 comes out to be plus 15 centimeters. Is it clear, everyone?
Yes, sir.
So this is the object for the first lens, and the image for the first lens is 15 centimeter from the lens. So 15 centimeters means here. This is the image for the first lens, I1. And this is image for first lens. Image for first lens. The image of first lens is at the optical center of the third lens. So this is the object for first lens. Now think. Now I have to solve this second lens. What is the object for second lens?
I1.
I1, right. So this image for the first lens will act as an object for the second lens. So this is object for second lens. This is object for second lens. And how much is this distance? The distance between this and this
5.
10 centimeter, right? Here to here. So for second lens, lens 2, your object distance is something, it's not 0. Object distance is 10 centimeter plus 10 centimeter. Second lens is a concave lens. Focal length is minus 10. Get the value of image distance. Do it. Get the value of V2 first. Very good, Noor. Very good, Abdullah. Mariam. No, Ahmed. Ahmed, just check your calculations. Fatma, Nazira, Sania. Answers. Just put these values in the lens formula. It's straight. No, Amalia. Again, you're making mistakes in subtraction. 1 by V2 minus 1 by U2 is 1 by F2. Amalia, do it again. So 1 by V2 is 1 by F2 plus 1 by U2. Fatma, Sania, is it 1 by V2 is this, na? So how much is V2? You're right. Up to here, you are right, but it's 1 by V2. You need to calculate V2. No, no, Sania. No. 1 by 0 is infinite. Na? See, you have 1 by V2 is 1 by F2. How much is F2? It's 1 by minus 10. Plus 1 by U2. How much is 1 by U2? It's 10. So gets cancelled out. 1 by V2 is 0. Which implies your V2 is infinite. So for second lens, the image is at infinity. Let's do it for the lens third. See, for the third lens, the image of second lens is the object for third lens. So for third lens, your object distance is at infinity only. U3 is infinity. F3 is given. How much is F3? F3 is 30 centimeter. At least do this 30 centimeter. Get the value of V3. Try the value of V3. Very good. Yes, Noor, Abdullah, right answer. Right, Ahmed, it's correct answer. I'm waiting for others. Get the value of V3 first. No. Let's see where it will be. No, not at the optical center. You're getting 30 now. So it's from here at 30 centimeter. So it's 1 by V3 minus 1 by U3. No, Sania, it's 1 by F3. So 1 by V3 is minus 1 by infinity is 1 by F3, which is 1 by 30. So you will get 1 by V3 is 1 by 30. So when you take reciprocal on both the sides, you get V3 is 30 centimeter. So its 30 final image is here. 30 centimeter from this lens. This is I3. This is it. Just complete the ray diagram and then write calculations.
Sir,
Yes.
sir, I2 was infinite, right?
Yeah. Yes, I do.
Calculating the image distance from I1.
See, this race goes here. Then it would have meet here, but since there is another refraction, it will become parallel, and then finally your ray will converge. Okay, that's a ray diagram.
Okay.
So this finish your refraction. After refraction, we have the last topic, which is optical instruments. So let's start with optical instruments. I'm just giving a brief introduction of optical instruments. We'll start it in the next class only. But please note this question. I will again share an assignments of some 4 or 5 questions based on lens formula. Try to go through it. Abdullah, prism is not a part of syllabus. We'll do prism, but after this optical instruments. So let me
It's
finish
deleted?
optical. Yes, prism is a deleted part of syllabus. Reflection is deleted, prism dispersion is deleted part. Just have refraction and optical instrument in detail. We'll do prism, but after the optical instruments. I'll give you an introduction of prism, but after optical instruments. Okay, written. No, this prism formula is not a part of this year's syllabus. It's a deleted part, but we'll discuss it. Someone from you was telling that you have done this prism in your school.
Yes, sir.
I will repeat prism, but it's not a part of CBSE syllabus. The next is optical instruments. So in your syllabus, you have 3 optical instruments. One is eye. Eye is not a part of syllabus now. Then you have microscope. You have 2 types of microscope. In fact, 3 types of microscopes. We have refracting type microscope. What refracting is in our syllabus. So we have 2 types of microscope. One is simple microscope. Another is compound microscope. Then you have telescope. You have 2 types of telescope. One is refracting type. Another is reflecting type. So these are the optical instruments in syllabus, and this is also 5-marker questions usually. Eye is deleted. It's not in syllabus for last 5 years. But to do microscope and telescope, you should know some basics about eye. So let's do few basic things upon eye. So in optics and physics, 2 parts of eye are important. One is eye lens and another is retina. These 2 parts of eye are important for physics. Eye lens is a convex lens having variable focal length. Eye lens is a converging lens with variable focal length. And retina is nothing but the screen. Retina is screen. That's eye. A converging lens with a variable focal length. That's eye. Next is near point and far point. So near point is the closest distance from the eye. Closest distance from eye that can be seen. So we call this as 25 centimeter. For a normal eye, it's 25 centimeter. This is known as least distance for distinct vision. Least distance for distinct vision. So if you place an object less than 25 centimeter, then you can't see that object through eye. It won't be visible. least distance for distinct vision. Similarly, you should know far point of an eye. It's infinity. Means the farthest you can see from an eye is infinity. That's for a normal eye. Just note it down. In almost every numerical, we'll be using least distance and far point of the eye. So you should know that least distance is 25 centimeter and far point is for a normal eye, it's infinity. Written?
Yes, sir.
Next. See, in optical instrument, we will be calculating angular magnification. So see, what is angular magnification basically? So this is your object and this is your eye. Angular magnification is the ratio of angle subtended by image and object on the eye. This is your object. It's subtending some image on the eye, angle on the eye, then you can have an image. It's also subtending some angle on the eye. The ratio of angle subtended by image and object on the eye is angular magnification. So instead of linear magnification, in linear magnification, we take height of image and object. In angular magnification, we don't take height, we take ratio of angle subtended by image and object on the eye. That's angular magnification. We represent it by capital M, and this is this angle beta by angle alpha. So we don't calculate linear magnification for it. We calculate angular magnification to it. Written?
Yes, sir.
Okay, so I will stop here. We'll start and finish this in the next class. So we'll try to finish this compound microscope and everything in the next class. The small derivations. Okay, so let's stop here. We'll continue this in the next class. Huh?
Thank you, sir.
Thank you, sir.
Sir,
Yes,
sir, prism is, I guess, there in the syllabus. It's written over here.
yes. Noor have sent. Just let me check if it is in the syllabus, then we will discuss it. Alright. It's okay. Stop here.
Thank you, sir.
Okay. Allah Hafiz.